1, section 111. So on this one, I skip 1.1 and just jump to 1.2 looking at function machines. So at the function factory, a number is put into the top of a function machine, and the machine puts out another number depending on how it is programmed. In the illustration at right, the worker put in a 3 and it kicked out an 8 because it squared the 3. 3 times 3 is 9, minus 1 is 8. This machine is programmed to square the numbers to subtract 1. A diagram of the machine looks like the figure at right. A customer brings in a box of mixed integers as inputs into the function machine. She wants you to program a function machine so that the output is always negative. Your manager suggests negative x over 2 minus 10. Did the store manager make a good suggestion? Are there any inputs that will not meet the customer's needs? Well, a couple of things. First of all, this ... means it goes forever in this direction, and this ... means it goes forever in this direction. So we're really talking about any number. And I think the thought is she wants you to program it so it's always negative. For instance, if I plug 0 in here, I get 0 minus 10, which gives me negative 8. So again, if I plug 0 in for x, I'm going to get 0 over 2, which would be 0 minus 10. I think I said negative 8, but it's negative 10. I don't know why I said negative 8. But long story short, that is going to be a negative number. So the question is there any way I can make this end up being a positive number? Well, what if I plug in negative 20? If I plug in a negative 20, a negative is positive, and I'm going to get 10 minus 10, which is 0. So obviously 0 is not a negative number. So I would say that the manager was incorrect, because any number that's smaller than negative 20 will actually make this thing go positive. For instance, if I plug in a negative 30, I'm going to get a negative 30 is positive 30 over 2 minus 10, which would be 15 minus 10, which would be 5, and I would get a positive number. So ironically, the larger the number I plug in, it's going to be negative. The smaller the number I plug in, it will actually turn into a positive number. So the manager needs to rethink that. Sometimes two machines at the function factory are stacked on top of each other. When a value for x is input into the first machine, an output value comes out. That output then becomes the input for another machine. So over the years, kids get a little bit confused. They think you plug -1 in here and in here. That's not the case. Whatever comes out of here is what ends up getting plugged in. So it says, work together with your team to determine the outputs from each of the function machines at right. Each member of your team should be able to explain. So let's go ahead and plug -1 in. If I plug -1 into this top machine, I will get -3 plus 1, and I will get -2. So that's the output, which means I'm now going to plug -2 in here. So I will get -2 squared. Obviously, that means -2 times -2. A negative times a negative is positive. 2 times 2 is 4. So if I plug -1 into the first machine, it will turn into a -2, which I will plug into the second machine, and it will end up being 4. It says work together with your team to determine the outputs from each of the function machines at right. Each member should be able to explain. And a customer has ordered a negative number. What number, if any, could you input in to the top machine so that it comes out negative? Well, this is a bit of a trick question, because the bottom machine is going to square it. So if I plug in a negative number, -2 squared ends up being +4. If I plug in 0, 0 squared is 0. And if I plug in a positive number, 2 squared is 4. So the lowest output I'm ever going to get here is 0. I'm never going to be able to get a negative. So kind of a trick question there. It's not going to happen. And then finally, let me close this, and we will pull up 1-4. Okay, so on 1-4, it says obtain resource page 11D. It just kind of looks like this, and it has the, actually, I think I don't know. This might actually be the jobs, and 11C might, yeah, 11C is the team roles. 11D just looks like these function machines. So we don't really need that, honestly. It just has the equations sort of written in, like 4x minus 32 here, and x minus 2 squared, and 1 over x. And we can arrange those in any order we want. So it says to help you work together, we're going to do the team roles. I'm not really going to worry about the team roles, but it says suppose that 0 is input in the first machine and negative 31 is output and is the output of the last machine. Are there any of these functions that could not possibly be the last machine? So they're saying, is there any of these that is going to make the final answer going to be a positive or a 0 and not a negative? So yeah, I would say this one couldn't possibly be last. This one can't be last because it's always going to spit out a positive number like we talked about with that square. Are there any of these functions that could not possibly be first? Well, yeah, I don't know if you guys know this, but if you plug 0 in the denominator of a fraction, it breaks the fraction. Essentially, you're saying is how many times does 0 go into 1? And it doesn't. You can't divide by 0. So you can have 0 on top. 0 on top equals 0. But 0 on the bottom is what's known as undefined, and it breaks the fraction. It's not possible. So we would go back over here, and I would say, well, I definitely am not allowed to have this one be first. And it says, what will be the final result to get negative 31 out? Well, I'll be honest with you, I don't know the answers to D and E, so I'm going to pause the video for a second and solve these so you don't have to sit here and watch me go through all this. Okay, so I've kind of played with these a little bit, and we know we want to plug in, so we'll go to D. We know we're going to plug 0 into the first function machine. And if we plug 0 into the x minus 2 squared machine, we'll get 0 minus 2 is negative 2, and negative 2 squared is 4, so it will spit out a 4. So that's our first machine. Then I will plug 4 into the second machine, which is going to be the 1 over x. If I plug that in, I get 1/4 as my output. And I'm kind of running out of room here. And I will plug that into the third machine, which would be 4x minus 32. So one of my favorite things here is cross-canceling. Let's take a look here. If I plug 1/4 into this, I now have the ability to cross-cancel. Those 4s are going to cancel. It's going to be 1 minus 32, so I get minus 31. So that'll be the order of the machines. The first one I will use is the x minus 32 squared. The second one I will use is the 1 over x machine. And the third machine I will use is the 4x minus 32. If we were to look at E, we know that we want to plug 1/7 into the first machine. Well, if I plug 1/7 into the first machine, I'm going to plug it into the 1 over x machine. Now, this is going to be a little bit interesting, so I'll plug this in. We get a triple stack. We're going to get 1 over 1/7. And I'll be honest with you, I do not like looking at fractions that look like this, where it's kind of a triple stack. I think it looks a lot easier if you say 1 divided by 1/7, which is really what this is saying, right? We're saying 1 is divided by 1/7, but if we remember, we never divide fractions. We always multiply by the reciprocal. So we're actually just going to get 7 after all of that, which is kind of interesting. So now, again, I'm kind of running out of room here. I'm going to take that 7 that I get out of the first one, and I'm going to plug it into the second equation, which is going to be the 4x minus 32. So 4 times 7 minus 32 is going to be 28 minus 32, which will give us negative 4 out. So this will be the second one. And then I'll take that negative 4 and I will plug it into the third machine. That third machine will be the x minus 2 squared machine. So I will get negative 4 minus 2 squared. I will get negative 6 squared, which is 36, which is what we were looking for. So on D, first machine, second machine, third machine, and on E, first machine, second machine, third machine. I believe after the notes there's a problem 1-5 that I usually just kind of leave as a challenge, but I don't really do in class.